Hello everyone, welcome to Physics Wala, India's most loved learning platform. ನಾನು ನಿಮ್ಮ ಫಿಸಿಕ್ಸ್ ಫ್ಯಾಕಲ್ಟಿ ಮಲ್ಲಿಕಾರ್ಜುನ್. ಸೋ ಫಾರ್ ನಾವು ಮೋಷನ್ನ ಪ್ಲೇನ್ ಲಾಸ್ ಆಫ್ ಮೋಷನ್ ಬಗ್ಗೆ ಎಲ್ಲ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಬರ್ತಾ ಇದ್ದೀವಿ. ದಿಸ್ ಇಸ್ ಅವರ್ ಥರ್ಡ್ ಲೆಕ್ಚರ್ ಆನ್ ಲಾಸ್ ಆಫ್ ಮೋಷನ್. ಓಕೆ, ಲಾಸ್ ಆಫ್ ಮೋಷನ್. ಈ ಕ್ಲಾಸಲ್ಲಿ ಏನೇನೆಲ್ಲ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ ಅನ್ನೋದನ್ನು ಒಂದ್ಸಲ ಹೇಳ್ತೀನಿ. ಸೊ ಪುಲಿ ಮಾಸ್ ಸಿಸ್ಟಮ್ ಬಗ್ಗೆ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡಿಸ್ಕಸ್ ವಾಟ್ ಈಸ್ ಅ ಪುಲಿ and a mass and the system together, and we are going to talk about spring mass system, and then we are going to talk about pseudo force andre enu, friction alli yav tarada friction ide. So far now friction anna balsa illa. Newton laws of motion alli we always said the surface is smooth, right? Now we will take into the account of friction and solve problems. So before we go into the topics, first thing first, always revision. So last class we applied Newton laws of motion, mainly the Newton's second law of motion, to get the value of acceleration, right? What did we do? We said F is equal to dp by dt, or F is equal to ma, right? We idanna now separately applied along x and y direction, right? We applied this one separately along x and y, applied separately along x and y. So then we got acceleration in x direction and acceleration in y direction. Most of the time acceleration in y direction came out to be 0. We said there is no acceleration y in y direction, the system is in equilibrium in y direction anta helidvi. Normal forces between the surfaces anta kuda adra bagge kuda ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. when we take two blocks, right, a block on block, right, we have a block on block. So in that case ಏನಾಗುತ್ತೆ, this one will apply normal reaction on this block in this direction. In reaction to that, this block will apply normal reaction on this one in this direction. So similarly another condition, ಈ ತರ ಬ್ಲಾಕ್ ಸರ್ಫೇಸ್ಗಳು ಇದ್ದಾಗ ಕಾಂಟ್ಯಾಕ್ಟ್ ಅಲ್ಲಿ ಇದ್ದಾಗ, so this block will apply normal on this one in this direction, and on this one normal is in this direction. These are all normal reaction force. Tension in a string ಬಗ್ಗೆ ಕೂಡ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಸೊ ಒಂದು ಬ್ಲಾಕ್, ರೈಟ್, ಮಾಸ್ m1 ಕನೆಕ್ಟೆಡ್ ಟು ಅನದರ್ ಒನ್ ಮಾಸ್ m2, ರೈಟ್. ಈ ಕಂಡೀಷನಲ್ಲಿ ನಾನು m2 ಮೇಲೆ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸನ್ನು ಅಪ್ಲೈ ಮಾಡಿದರೆ, ರೈಟ್, m2 ಮೇಲೆ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸನ್ನು ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ m1 ಯಾಕೆ ಮೂವ್ ಆಗಬೇಕು? m1 ಯಾಕೆ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂದರೆ ದಟ್ ಫೋರ್ಸ್ is transmitted through the string in the form of tension. So if I take any point, ಯಾವುದೇ ಪಾಯಿಂಟ್ ಅನ್ನು ತಗೊಂಡ್ರೆ, right, this point is pulled in this direction by tension and pulled in the opposite direction by tension. ಯಾಕಂದ್ರೆ ಐಡಿಯಲ್ ಕೇಸಲ್ಲಿ tension, that string, right, is massless. For that to be massless, acceleration could be there, acceleration ಇರಬಹುದು. But when I say massless, net force ಏನಿರುತ್ತೆ? 0 ಇರುತ್ತೆ. ಆ ನೆಟ್ ಫೋರ್ಸ್ 0 ಇರಬೇಕು ಅಂದರೆ ಟೆನ್ಷನ್ ಆಕ್ಟಿಂಗ್ ಇನ್ ಬೋತ್ ದ ಸೈಡ್ಸ್ ಶುಡ್ ಬಿ ಸೇಮ್ ಇನ್ ಐಡಿಯಲ್ ಕಂಡೀಷನ್. ಸೊ ಎನಿ ಪಾಯಿಂಟ್ ಯು ಟೇಕ್, this point you take, tension is pulling in this direction. This point you take, tension is pulling in opposite directions whose magnitude is equal, their action and reaction. Similarly block on an inclined plane ಕೂಡ ನಾವು ನೋಡಿದ್ವಿ. when we had a block, right, ಒಂದು ಬ್ಲಾಕ್ ಅನ್ನ ಇನ್ಕ್ಲೈನ್ ಪ್ಲೇನ್ ಮೇಲೆ ಇಟ್ಟಾಗ ದಟ್ ಇನ್ಕ್ಲೈನ್ ಪ್ಲೇನ್ ಇಸ್ ಅಟ್ ಅನ್ ಆಂಗಲ್ ಥೀಟಾ. ಈ ಥರ ಕಂಡೀಷನ್ಲಿ ಇದರ ಮೇಲೆ ಒಂದು ಬ್ಲಾಕ್ ಅನ್ನ ಇಟ್ಟಾಗ ದಿಸ್ ಬ್ಲಾಕ್ ವಿಲ್ ಸ್ಲೈಡ್ ಆನ್ ದ ಸರ್ಫೇಸ್ ಆಫ್ ದ ವೆಡ್ಜ್ ವಿತ್ ಅನ್ ಆಕ್ಸಿಲರೇಷನ್. ದಿಸ್ ಆಕ್ಸಿಲರೇಷನ್ ಇಸ್ ವಾಟ್ ವಿ ಸೆಡ್ ಇಸ್ g sin theta. We said that this acceleration is g sin theta along the wedge, correct? So these things are clear. Now let us look at what a pulley mass system is. A pulley mass system is a combination of pulley, right? This one, idu ನಾವು pulley anta kariteve, right? And these are masses m1 and m2 connected by a string, right? Connected by a string. So pulley mass system andre, right, system of mass and pulley connected by connected by string andre ಒಂದು ಹಗ್ಗ, right? That is ideal. In ideal cases, what are the assumption is the rope is massless. ಈ massless rope ನ ನಾವು ideal condition ಅಂತೇಳಿ ಕರಿತೇವೆ. This rope is massless and inextensible. ಅದರ ಲೆಂತ್ ಅನ್ನು ನಾವು ಇನ್ಕ್ರೀಸ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ ಅಥವಾ ಡಿಕ್ರೀಸು ಕೂಡ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ದ ಪುಲ್ಲಿ ಇಸ್ ಮಾಸ್ಲೆಸ್. ಇದೇನು ಈ ಪುಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊತಾ ಇದೀವಿ, ಇದರ ಮಾಸ್ ಈಸ್ 0 and frictionless ಅಂದರೆ it will not rotate. See, pulley is smooth and massless, which means whenever there is a rope, ಅದರ ಮೇಲೆ ರೋಪ್ ಇದ್ದಾಗ the rope will just only slide. ಈ pulley is not rotating, okay? This pulley is not going to rotate. If there is friction, pulley is going to rotate. The pulley is just there facilitating smooth movement of the rope. ಅದರ ಮೇಲೆ pulley ಮೇಲೆ ಸ್ಮೂತ್ ಆಗಿ ರೋಪ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ, ಬಟ್ pulley itself is not rotating, which means rotation is not there. No rotation of the pulley, right? No rotation of the pulley, which means it is frictionless, right? So observe the rope at any point, right? At any point observe, at any point I look at the rope, so every point will be pulled in opposite direction by tension, right? So this tension is pulling this point in upward direction because of this fixed surface, fixed support, and it is pulling downward because of this m1 weight. Similarly on this side also, tension is pulling upwards this point and tension is pulling downwards this point because of m2. The tension is pulling downwards, right? But this one is also there, right? This one is also there, right? This one is also there. Here, if you look at this point, right? If you look at this point is pulled upwards, right? By tension. But since it is a different string agirodrinda, I call this as T dash. This point is pulled upwards by T dash. See guys, observe the pulley now. Observe the pulley. The pulley is very small. Ideally, we say that pulley is small also and small, right? Ideally, pulley is massless, frictionless and small, right? So now you observe the pulley massless irodrinda I apply NLM to the pulley, right? To the pulley. So what is NLM? F is equal to MA. F net is equal to MA. See guys, observe the pulley. What are the forces acting on the pulley? Pulley is being pushed up by T dash and pulled down by this tension and this tension, right? How do you know? By writing the FBD of pulley, right? FBD of pulley. I'll write FBD of pulley. Observe here. FBD of pulley I am writing here. You have a pulley, right? This pulley is upwards pulled by tension T1, downwards by T and another force T. See, I am not writing M1G, M2G because they are not directly acting on the pulley. Free body diagram barita directly ಯಾವ್ದು forces act ಆಗ್ತಾ ಇದೆಯೋ ಅದನ್ನ ಮಾತ್ರ ಬರೆಯೋದು, right? So here observe guys, what is the net force? Net force is T1, this T1, right, minus T minus T, because there are two forces in the downward direction. T1 minus T minus T, or you can call this as T dash also, not a problem, is equal to mass into acceleration of the pulley, right? Acceleration, forget about acceleration. I don't know what is acceleration, but since the pulley is massless, right? Since the pulley is massless, what can we say? We can say that the net force on the pulley is 0. T1 minus T minus T is equal to MA. Since mass is 0, this term is going to be 0 because mass of the pulley is 0. So T1 is actually 2T, right? This T1 is 2T. Then only the net force on the pulley is 0. The net force on the pulley is 0 only when T1 is equal to 2T. Is that clear? So what did we do? We said pulley is massless. If pulley is massless, this tension in this string has to be 2 times of tension in one of the strings, correct? So if these masses are attached, right, these masses will have their own weight acting downwards, M1G and M2G, right? Because of these masses, because of the variation in these weights, there will be acceleration in the system, right? So that acceleration, how do we calculate that acceleration? I'll tell you. So you have mass M1, right? You have mass M2. Tension is acting in this direction, right? For any point here, tension is acting like this, right? This one, we said this tension is 2T. This tension we said 2T, correct? So in this case, why is the system going to accelerate? Why is the system going to accelerate? ಯಾಕೆ ಸಿಸ್ಟಮ್ ಆಕ್ಸಿಲರೇಟ್ ಆಗುತ್ತೆ ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ಹೇಳ್ತೀನಿ. ಸೊ M1 ನ ವೆಯ್ಟು M1G acting downwards, M2 ನ ವೆಯ್ಟು M2G acting downwards, right? If I assume that there is an acceleration in the system in this direction, so how do we get this value of acceleration? I'm going to tell. See, what do we do? Write the free body diagram of M1, right? FBD of M1 I am writing. See guys, FBD of M1, when I write M1, what are the forces acting on M1? M1 ಮೇಲೆ ಯಾವೆಲ್ಲ ಫೋರ್ಸಸ್ಗಳು ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ? ಇಟ್ಸ್ ಓನ್ ವೆಯ್ಟ್. ಫಸ್ಟ್ ವೆಯ್ಟನ್ನು ಬರಿತೀವಿ ಯಾವಾಗಲೂ. M1G ಡೌನ್ ಇದೆ, ರೈಟ್? ಅಂಡ್ ಟೆನ್ಷನ್ ಈಸ್ ಪುಲ್ಲಿಂಗ್ ಇಟ್ ಅಪ್, ರೈಟ್? ಟೆನ್ಷನ್ ಈಸ್ ಪುಲ್ಲಿಂಗ್ ಇಟ್ ಅಪ್. ಸಿ, tension is pulling it up. Tension is always a pulling force. It's not a pushing force, right? So tension is pulling it up. Because tension is pulling it up, and I consider, navenana consider madkondvi, acceleration e direction alli ide anta consider madkonde. So for that acceleration e direction alli idre, idara acceleration will be in upper direction. E block ಕೆಳಗಡೆ ಹೋದ್ರೆ ಈ ಬ್ಲಾಕ್ ಮೇಲ್ಗಡೆ ಹೋಗುತ್ತೆ, correct? So here the acceleration is in this direction, correct? So if I apply NLM ನ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಯಾವ ಬ್ಲಾಕಿಗೆ? M1 ಗೆ NLM ನ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. NLM2 apply NLM2 for mass 1, correct? mass 1 ಗೆ NLM2 ನ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ T minus M1G ಈ ಎರಡರಲ್ಲಿ ಆಕ್ಸಿಲರೇಷನ್ ಆ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರಬೇಕು ಅಂದ್ರೆ ಯಾವುದು ಸ್ಟ್ರಾಂಗರ್ ಫೋರ್ಸ್? ಟೆನ್ಷನ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಸ್ಟ್ರಾಂಗರ್ ಫೋರ್ಸ್, ನೋ? T minus M1G is equal to M1 into acceleration. Total net force is equal to mass into acceleration. Similarly, I write FBD of M2 na barita idini. FBD of M2 na barita idini. See, FBD of M2, observe here, what are the forces acting on M2, right? Its own weight, M2G is acting downward, and tension T is acting downwards. Idra acceleration yav direction alli ide? Downward ide. This is my consideration, okay? But this acceleration has to be downward andre which force has to be stronger? M2G has to be stronger. Similarly, I apply NLM here. So M2G minus tension is going to be M2 into A. This is my equation number 1 and this is equation number 2. So what I do is take equation number 1 and equation number 2. Equation number 1 ಏನide? T minus M1G is equal to M1A. This is equation number 1. Equation number 2, M2G minus T is equal to M2A. This is equation number 2, right? I want to calculate acceleration, right? I have already written acceleration ಇದಾಗಿರುತ್ತೆ, ಟೆನ್ಷನ್ ಇದಾಗಿರುತ್ತೆ. ಅದನ್ನು ಯಾವ ಥರ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ ಅನ್ನೋದನ್ನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಫಸ್ಟು. ಸೊ ಈ ಡೆರಿವೇಷನ್ ನಿಮ್ಮ ಬೋರ್ಡ್ ಎಕ್ಸಾಮಿಗೆ ಬರಲ್ಲ. ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸಿಗೆ ಈ ಡೆರಿವೇಷನ್ನ ನೆನಪಿಟ್ಕೊಳ್ಳೋ ಅವಶ್ಯಕತೆ ಕೂಡ ಇಲ್ಲ. ಬಟ್ ಕ್ವಿಕ್ಕಾಗಿ ಯಾವ ಥರ ಸಾಲ್ವ್ ಮಾಡ್ತೀವಿ ಅನ್ನೋದಕ್ಕೆ ನಿಮಗೆ ಫಾರ್ಮುಲಾ ಬೇಕು. ಆ ಫಾರ್ಮುಲಾನ ರಿಮೆಂಬರ್ ಮಾಡಬೇಕು ಅಂದರೆ ನಿಮಗೊಂದು ಐಡಿಯಾ ಇರಬೇಕು ಯಾವ ಥರ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ವಿ. ಅದಕ್ಕೋಸ್ಕರ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಇಯರ್ ಯು ಆ್ಯಡ್ equation 1 and 2, you add equation 1 plus 2. If I add equation 1 plus 2, tension is getting cancelled. But we have M2G minus M1G. M2G minus M1G, right, equal to M1A plus M2A, correct? When I added 1 and 2, TT cancel ಆಯಿತು. So here acceleration ಬೇಕು ಅಂದರೆ ಈ ಸೈಡಲ್ಲಿ ಆಕ್ಸಿಲರೇಷನ್ನ ಕಾಮನ್ ತಗೋ M1 plus M2 and here G ನ ಕಾಮನ್ ತಗೋ M2 minus M1 into G, right? So acceleration ಈ M1 plus M2 ನ ಕೆಳಗಡೆ ಕಳಿಸು M2 minus M1 divided by M1 plus M2 into G, correct? The expression which we have here, M2 minus M1 divided by M1 plus M2 into G. But how do we remember it? Quick ಆಗಿ ಯಾವ ಥರ ರಿಮೆಂಬರ್ ಮಾಡ್ಕೊತೀನಿ? See, M2 into G ಏನು? M2 into G. See, acceleration ಈ direction ಅಲ್ಲಿದೆ ಅಂದರೆ, so M2G is a supporting weight, correct? M2G is a supporting weight, M1G is a opposing weight. So M2G is supporting weight minus M1G is opposing weight. Acceleration ಈ direction ಅಲ್ಲಿದೆ, but M1's weight is in this direction. So M1 is an opposing weight, right? M1G is an opposing weight. So supporting weight minus opposing weight divided by total mass. So acceleration. Either you remember this formula or the second one, whichever you remember. ಈ ಥರ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಲ್ಲಿ ಆಕ್ಸಿಲರೇಷನ್ನ ಕ್ವಿಕ್ ಆಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೋದು. M2 minus M1 by M1 plus M2 into G. Then what about ಟೆನ್ಷನ್ನ ಯಾವ ಥರ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀನಿ? ಟೇಕ್ equation number 1, substitute the value of A. So equation number 1 ಅನ್ನು ತಗೊತಾ ಇದ್ದೀನಿ. Put A in equation number 1. Equation number 1, which is T minus M1G is equal to M1 into A. A ಏನಿದೆ? M2 minus M1 divided by M1 plus M2 into G. See guys, ಈ M1G ನ ಈ ಕಡೆ ತರ್ತಾ ಇದ್ದೀನಿ. T is going to be equal to M1G plus M1, right? M1 M2 minus M1 square divided by M1 plus M2 into G. ಇಲ್ಲಿ M1 plus M2 ನ LCM ತಗೊತಾ ಇದ್ದೀನಿ. M1 plus M2 ನ LCM ತಗೊತಾ ಇದ್ದೀನಿ. So M1 plus M2 is my LCM. So in that case, this term is going to be M1 into M1. So M1 square, M1 into M2. So M1 M2 plus M1 M2 one more time, M1 M2 minus you have M1 square. Whole common is G. Here M1 square cancel. You have tension is equal to 2M1 M2 divided by M1 plus M2 into G, right? See, observe the expression 2M1 M2 divided by total mass into G. So ಈ ಥರ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ masses ಅನ್ನು ಕೊಟ್ಟಾಗ you can directly get the value of tension and acceleration, correct? ಡೈರೆಕ್ಟ್ ಆಗಿ acceleration ಮತ್ತು tension ಅನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು. ಒಂದು ಪ್ರಾಬ್ಲಮ್ನ ಅವೆರಡು ಪ್ರಾಬ್ಲಮ್ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಕ್ವಿಕ್ ಆಗಿ ಸಾಲ್ವ್ ಮಾಡಿ ಬಿಸಾಕೋಣ, ರೈಟ್? ಫೈಂಡ್ ದ acceleration of the mass and the tension in the string for the given pulley mass system. ಈ pulley mass system ಅಲ್ಲಿ ಒಂದು 6 kg ಬ್ಲಾಕ್ ಇದೆ, another one is 8 kg block, right? They are connected by a string. So we need to calculate this tension, right? This tension T, and also we need to calculate acceleration of the system, right? Acceleration of the system. So acceleration of the system na nanu A anta karkondre, right? Which one is higher weight? 8G, right? Because 8 is having more mass than 6. So 8G is in this direction. This is going to be supporting weight and this is going to be opposing weight because the body is going to accelerate like this. 8 will go down, alva. 8 weight is more than 6 weight. So 8 will go down. So 8 is a supporting weight. 6 is a opposing weight. So 6G. So I apply that formula. A is going to be equal to supporting weight minus opposing weight divided by total mass. Total mass. What is supporting weight? Supporting weight is 8G, right? It's not 8. 8G. Opposing weight 6G divided by total mass 8 plus 6. 8G minus 6G, 2G divided by 14 or G, 2G divided by 14 or G divided by 7. G divided by 7. Acceleration is going to be G divided by 7 or if I use the formula, right? If I use the formula m2 minus m1 divided by m1 plus m2 into G. m2 minus m1 ಏನಿದೆ 8 minus 6 divided by 8 plus 6 into G. I get the same answer, G by 7, which is equal to 1.42. 10 divided by 7 is 1.42 meter per second square. This is acceleration. Then how do we calculate tension? How do we calculate tension? Tension ki formula gottide. Tension T is 2 times m1 m2 divided by m1 plus m2 into G. m1 ಏನಿದೆ? m1 is 6, right? So 2 into 6 into 8 divided by 6 plus 8 into G, which is standard value 10. So 6 into 8 is 48 into 10, 480. So 480 divided by 14, which is 480 by 7. Tension is 480 by 7. Guys, observe here. How quickly I'll identify what type of answer is going to come. If this was 490, answer ಏನಿರುತ್ತೆ? Directly 70 ಇರುತ್ತೆ. But 490 ಅಲ್ಲ ಇದು. 483 ಆಗಿದ್ರೆ answer will be 69. So answer is close to 69 and greater than 68. So if you calculate the exact value, 68.57 is the answer. T is going to be 68.57. So using that formula R, just by directly applying FBD, right? Just by directly applying FBD of one of the masses, I'm going to write FBD of 6 kg, right? How do we write FBD of 6 kg? Look at 6 kg block. Tension is pulling it in this direction. Its own weight is pulling it in this direction, 6G, and it is accelerating in upward direction. I am writing 6G, not 8G. Acceleration ಮೇಲಿದೆ. So block ಮೇಲೆ ಹೋಗಬೇಕು ಅಂದ್ರೆ T minus m1G should be equal to m1 into A, correct? Then only block will go up. T ಏನಿದೆ? T is what I am calculating. T is going to be equal to m1 is 6, right? A we calculated 1.42 plus G is 10. So if you calculate it, 6 into 11.42, T is going to be 68.57. Or you could have written FBD of 8 also. If you had written FBD of 8 ಅನ್ನ ಬರೆದ್ರೆ FBD of 8 kg ನ ಬರೆದ್ರೆ, in that case m2G minus T is going to be equal to m2 into A. Using that also we can calculate tension. This also gives tension. But which one is easy? This one is easy, right? This one is easy method. By remembering the formula, you are able to quickly get the answer. So remember the formula for tension and acceleration. We can directly get the answer. Find the acceleration of the system and the tension in the strings as shown, right? Strings as shown. See guys, ಇಲ್ಲಿ ಒಂದು 6 kg ಬ್ಲಾಕ್ ಇದೆ, ಇಲ್ಲಿ 2 ಬ್ಲಾಕ್ ಇದೆ. ಇಟ್ ಇಸ್ ನಾಟ್ ಆರ್ ಪ್ರೀವಿಯಸ್ ಕಂಡೀಷನ್, ಅಲ್ಲಿ 2 ಇರ್ತಿತ್ತು, ಇಲ್ಲಿ ಟೋಟಲ್ 3 ಬ್ಲಾಕ್ಸ್ ಇದೆ. ಸೊ ದಿಸ್ ಒನ್ is your string 1, right? This one is string 1, this one is string 1. At any point I see this point is pulled up, right, by tension. Similarly, on this side also tension, tension. We have tension, tension. But there is another string, right? If you look at this point is pulled up by tension, tension. So this tension, will it be equal to this tension or different? It will be different. So this tension are going to be different. So this is T1, T1, T2. Correct? Here we need to calculate those two values of tension along with the acceleration of the system. First of all, acceleration ಕಂಡುಹಿಡಿಯೋಣ. acceleration ಕಂಡುಹಿಡಿಯೋಣ. ಟೆನ್ಷನ್ ಬಗ್ಗೆ ಮರ್ತುಬಿಡಿ. acceleration ನಾನು ಯಾವ ಥರ ಕಂಡುಹಿಡಿತೀನಿ? ಸಿಂಪಲ್ ಫಾರ್ಮುಲಾ, acceleration is equal to supporting weight minus opposing weight. Supporting weight minus opposing weight divided by total mass. Right? Here ಬ್ಲಾಕ್ ಯಾವ ಕಡೆ ಮೂವ್ ಆಗುತ್ತೆ? ವಿಚ್ ವೇಟ್ ಈಸ್ ಹೆವಿಯರ್ ಆ ಕಡೆ ಮೂವ್ ಆಗುತ್ತೆ. ಸೊ 6 kg weight is more than 3 plus 1 together. So the block is going to accelerate in this direction. So ಈ ಥರ accelerate ಮಾಡಬೇಕು ಅಂದರೆ ಇಲ್ಲಿ ಸಪೋರ್ಟಿಂಗ್ ವೇಟ್ ಯಾವುದಿದೆ? ಸಪೋರ್ಟಿಂಗ್ ವೇಟ್ ಬಂದು 6g ಇದೆ. ಸೊ this 6g is the supporting weight and this 4g is the opposing weight. 3 plus 1 together, 4g is the opposing weight. I am not worried about tension because we are not including internal forces. When I consider this whole thing as a system, I am not including tension. Supporting weight ಏನಿದೆ? 6g. Opposing weight ಏನಿದೆ? 2g divided by total mass m1 plus m2, which is 6g plus 3 plus 1, which is 6 plus 4. 6 plus 4. Acceleration ಏನಿರುತ್ತೆ? Acceleration 2g divided by 10. 2g divided by 10. G and 10 gets cancelled. So you have 2 meter per second square as the acceleration. Right? Now you have acceleration. ಈಗ ಟೆನ್ಷನ್ ಅನ್ನು ಯಾವ ಥರ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೋದು? ಈ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡೋಕ್ಕಾಗುತ್ತಾ? T is equal to 2 m1 m2 divided by m1 plus m2. We will be in a complex situation. But ಅದಕ್ಕೆ ಏನು ಮಾಡ್ತೀನಿ ಅಂದರೆ, ಸೊ ಈ ಸಿಸ್ಟಮ್ನ ಒನ್ ಮೋರ್ ಟೈಮ್ ರೀಕಾಲ್ ಮಾಡಿ. ಈ ಸಿಸ್ಟಮ್ನ ಒನ್ ಮೋರ್ ಟೈಮ್ ರೀಕಾಲ್ ಮಾಡಿ. 6 kg ಇದೆ, 3 kg ಇದೆ, 1 kg ಇದೆ. ಟೆನ್ಷನ್ ಈ ಡೈರೆಕ್ಷನಲ್ಲಿ ಆ್ಯಕ್ಟ್ ಆಗ್ತದೆ, ಇಲ್ಲಿ ಟೆನ್ಷನ್ ಈ ಡೈರೆಕ್ಷನಲ್ಲಿ ಆ್ಯಕ್ಟ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ಎಫ್ ಬಿ ಡಿ ಆಫ್ 6 kg ನಾನು ಫಸ್ಟ್ ಬರಿತಾ ಇದ್ದೀನಿ. ಎಫ್ ಬಿ ಡಿ ಆಫ್ 6 kg ಫಸ್ಟು ಬರಿತಾ ಇದ್ದೀನಿ. ರೈಟ್? 6 kg ಮೇಲೆ ಏನೆಲ್ಲ ಫೋರ್ಸಸ್ ಆ್ಯಕ್ಟ್ ಆಗ್ತಾ ಇದೆ ಒಂದ್ಸಲ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೊಳ್ಳಿ. 6 kg ಮೇಲೆ ಏನೆಲ್ಲ ಫೋರ್ಸಸ್ ಆ್ಯಕ್ಟ್ ಆಗ್ತಾ ಇದೆ? ಇಟ್ಸ್ ಓನ್ ವೆಯ್ಟ್ 6g is acting. See, this is direct force. ಡೈರೆಕ್ಟ್ ಆಗಿ 6 kg ಮೇಲೆ ಯಾವುದೆಲ್ಲ ಫೋರ್ಸಸ್ ಆ್ಯಕ್ಟ್ ಆಗ್ತಾ ಇದೆ ಅದನ್ನು ನಾನು ಎಫ್ ಬಿ ಡಿಲಿ ಇನ್ಕ್ಲೂಡ್ ಮಾಡ್ತೀನಿ. ಓಕೆ, ಸೊ ದಿಸ್ ಈಸ್ ಯುವರ್ ಟೆನ್ಷನ್ 1. ಆಕ್ಸಿಲರೇಷನ್ ಯಾವ ಡೈರೆಕ್ಷನಲ್ಲಿದೆ? ಆಕ್ಸಿಲರೇಷನ್ is in this direction, right? Apply NLM for 6 kg. So acceleration ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರಬೇಕು ಅಂದ್ರೆ 6g has to be greater than tension 1. 6g minus t1 is equal to 6 into its acceleration, mass into acceleration. Acceleration we got it as 2 meter per second square. So tension is going to be 6g, 6 into 10 minus 6 into 2. So tension is going to be 60 minus 12. 60 minus 12 alwa. So tension 1 is 48 Newton. So how do I calculate? Then how do I calculate T2? I write FBD of 1 kg. Why not 3 kg? I'll tell you why not 3 kg. FBD of 1 kg ಬರಿತಾ ಇದ್ದೀನಿ. 1 kg ಮೇಲೆ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಇಲ್ಲಿ, right? T2 is acting upwards. T2 is pulling 1 kg up and its weight is pulling it down, right? Which is 1 into g. ಇದರ acceleration ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿದೆ? ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿದೆ, which is 2 meter per second square. ಇದಕ್ಕೆ NLM ಅಪ್ಲೈ ಮಾಡು. T2 has to be greater than m1g, right? 1g, then only block will go up. 1g is going to be equal to mass into acceleration. Mass is 1 into acceleration, right? So T2 is going to be 10 plus 2, right? T2 is directly 12 Newton, right? T2 is directly 12 Newton. Instead of that, if I had written, right, free body diagram of 3 kg, I would have gotten T2. ಹೇಳ್ತೀನಿ ಯಾವ ಥರ ಅಂತ. 3 kg ಮೇಲೆ ಯಾವುದೆಲ್ಲ ಫೋರ್ಸಸ್ ಆ್ಯಕ್ಟ್ ಆಗ್ತಾ ಇದೆ? 3 kg ಮೇಲೆ T1 acting upwards, correct, and T2 acting downwards, T2 acting downwards, and its own weight is also acting downwards, correct. So and its own weight is also acting downwards, which is mg 3 kg ಬರೀತಾ ಇರೋದ್ರಿಂದ ಇದು 3 kg 3g. ಸೊ ಇದರ ಆಕ್ಸಿಲರೇಷನ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇದೆ? ಆಕ್ಸಿಲರೇಷನ್ ಇಸ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್. ನಾನು ಇವಾಗ ಇದಕ್ಕೆ NLM ನ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ, ಸೊ T2 ಪ್ಲಸ್ 3g, T2 ಪ್ಲಸ್ 3g, ರೈಟ್? ನೋ, ಆಕ್ಸಿಲರೇಷನ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇದೆ? ಅಬ್ಸರ್ವ್, acceleration is in upward direction, right? So acceleration is in upward direction because this is a opposing weight. Acceleration is in this direction. So here acceleration our direction alli irbeku andre T1 minus T2 minus 3g has to be equal to 3 into a. Illi T2 T1 everything together ಬರ್ತಾ ಇರೋದ್ರಿಂದ ಸ್ವಲ್ಪ ಕಾಂಪ್ಲಿಕೇಶನ್ ಆಗ್ತಾ ಇದೆ ಯಾವುದರಲ್ಲಿ? ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಅಲ್ಲಿ. ಸೊ ದಟ್ ಈಸ್ ವೈ we did not choose this method, choose this FBD, because it has many terms in it. It has many terms. So T1 48, T2 ಗೊತ್ತಿಲ್ಲ, right? Minus 3g 30, 3 into a is 6. So T2 is going to be, T2 ನ ಈ ಕಡೆ ಹಾಕೋ, 48 minus 30, it is 18 minus 6. We got the same answer. 12 Newton. But you have to do this much instead of just doing this much, right? So this is simple than FBD of which one? Than FBD of 3 kg. FBD of 3 kg, correct? So although we got the same answer, I would ask you to prefer writing the free body diagram which has only few terms in it, right? So free body diagram ಬರ್ದು ಸ್ಪ್ರಿಂಗ್ ಮಾಸ್ ಸಿಸ್ಟಮ್ ನ ಯಾವ ತರ ಸಾಲ್ವ್ ಮಾಡೋದು ಅನ್ನೋದು ಗೊತ್ತಾಯ್ತು. ಸೊ ಇವಾಗ ಸ್ಟ್ರಿಂಗ್ ಮಾಸ್ ಕ್ಲಿಯರ್ ಆಯಿತು. ಇವಾಗ ಸ್ಪ್ರಿಂಗ್ ಮಾಸ್ ಅಂದರೆ ಏನನ್ನೋದನ್ನು ಸ್ವಲ್ಪ ನೋಡೋಣ. ಸ್ಪ್ರಿಂಗ್ ಮಾಸ್, ರೈಟ್, ಒಂದು ಸ್ಪ್ರಿಂಗ್ ಇದೆ. ಸೊ ಆ ಸ್ಪ್ರಿಂಗಿಗೆ, ರೈಟ್, ಐ ಅಟ್ಯಾಚ್ ಅ ಮಾಸ್, ರೈಟ್, ಆ ಸ್ಪ್ರಿಂಗಿಗೆ ಐ ಅಟ್ಯಾಚ್ ಅ ಮಾಸ್. ಸೊ ಆರ್ ದಿಸ್ ಮಾಸ್ is applying some external force, F external, in this direction, right? This mass is applying some F external in this direction. So ee case alli, right, initially original length of the string was x. When I applied this external force, right, when I applied this external force, what happened? This spring is going to expand. This spring is going to expand, right? In that case, its length will become L plus x. The moment I take this external force, ಏನಾಗುತ್ತೆ? Spring wants to go back, alva? Spring ಎಳ್ದಿದ್ spring, the moment I leave that, it wants to go back. So go back ಆಗ್ಬೇಕು ಅಂದ್ರೆ, it wants to go back ಅಂದ್ರೆ, so there has to be some force in this direction, right? So that force is what we call as restoring force in the string. Right? So we say springs will have restoring force. Strings will have restoring force. Instead of expanding it, right? If I use external force to compress it, right? If I use external force to compress it, what happens to its length? Its length will reduce. Its length will ಏನಾಗುತ್ತೆ? L minus x ಆಗುತ್ತೆ, right? The displacement ಏನಾಗಿದೆ? x ಇತ್ತು. Sorry, the length, this has to be L. So L length ಇತ್ತು, right? x expand ಆದಾಗ, x length expand ಆದಾಗ ಇದರ length L plus x ಆಯಿತು. x length compress ಆದಾಗ ಇದರ length L minus x ಆಯಿತು. So in that case, the moment you take off this F external ನ ತೆಗೆದಾಗ, the spring will come back, right? So it will come back because of the restoring force in it. Observe guys, here this restoring force is ulta of the displacement. Here also this restoring force is ulta of the displacement. Displacement yav kade agide? Displacement in this direction. But force yav kade aagta ide? Force is in this direction. So we can say F restoring is directly proportional to negative of x. Here also this F restoring is directly proportional to negative of x. Both the cases F is proportional to that displacement, but it is opposite to that displacement. So combining these two and removing the proportionality constant, I can write F is equal to minus kx. F is equal to minus kx. Correct? Here k na ನಾವು ಏನಂತ ಕರಿತೀವಿ? Spring constant of the spring constant ಅಂತ ಹೇಳಿ ಕರಿತೀವಿ. ಇದರ ಯೂನಿಟ್ is going to be k Newton per meter. So unit is going to be Newton per meter. So ಯಾವ ಸ್ಪ್ರಿಂಗಿನ ವ್ಯಾಲ್ಯೂ k ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಇರುತ್ತೋ ಆ ಸ್ಪ್ರಿಂಗಿಗೆ we need to apply more force to compress than ಯಾವ ಸ್ಪ್ರಿಂಗಿನ ವ್ಯಾಲ್ಯೂ k ವ್ಯಾಲ್ಯೂ ಕಡಿಮೆ ಇರುತ್ತೋ ಅದಕ್ಕೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ. ಸ್ಪ್ರಿಂಗ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಜಾಸ್ತಿ ಇದೆ ಅಂದರೆ ಅರ್ಥ ಅದನ್ನು ಕಂಪ್ರೆಸ್ ಮಾಡೋಕ್ಕೆ ಅಥವಾ ಅದನ್ನು ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಮಾಡೋಕ್ಕೆ ನಾವು ಜಾಸ್ತಿ ಫೋರ್ಸನ್ನು ಅಪ್ಲೈ ಮಾಡಬೇಕು. ನಾವೆಲ್ಲ ಕಾಮನ್ ಆಗಿ ನೋಡಿರ್ತೀವಿ, ರೈಟ್? ಬೈಕಲ್ಲಿ ಶೇಕ್ ಅಬ್ಸರ್ಬರ್ಸ್ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ಅದನ್ನು ಯಾವ ಥರ ಡಿಸೈನ್ ಮಾಡಿರ್ತಾರೆ ಅಂದರೆ ಸ್ಪ್ರಿಂಗ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಶುಡ್ ನಾಟ್ ರೆಸ್ಪಾಂಡ್ ಫಾರ್ ಸ್ಮಾಲ್ ಕಲ್ಲಿತ್ತು ಅಂದರೆ ರೋಡಲ್ಲಿ ಅದು ಪುಟಿಬಾರ್ದು. ಓನ್ಲಿ ವೆನ್ ಯು ಕಮ್ ಅಕ್ರಾಸ್ ಅ ಬಿಗ್ ಆಂಪ್ ದೆನ್ ಇಟ್ ವಿಲ್ ರೆಸ್ಪಾಂಡ್, ರೈಟ್? ಸೊ ಆ ಥರ ಸ್ಪ್ರಿಂಗನ್ನು ನಾನು ಕಂಪ್ರೆಸ್ ಮಾಡಬೇಕು ಅಂದರೆ ವಿ ನೀಡ್ ಮೋರ್ ಎನರ್ಜಿ. ಆದರೆ ಪೆನ್ನಲ್ಲಿ ಇರುತ್ತಲ್ಲ ಆ ಸ್ಪ್ರಿಂಗನ್ನು ನಾನು ಕಂಪ್ರೆಸ್ ಮಾಡಬೇಕು ಅಂದರೆ ಐ ನೀಡ್ ಲಿಟಲ್ ಬಿಟ್ ಆಫ್ ಎನರ್ಜಿ, ಕರೆಕ್ಟ್? ಸೊ ದಟ್ ಹೌ ಮಚ್ ಎನರ್ಜಿ ಆರ್ ಹೌ ಮಚ್ ಫೋರ್ಸ್ ಇಸ್ ನೀಡೆಡ್ ಟು ಕಂಪ್ರೆಸ್ ಇಟ್ ಈಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಆಸ್ ಸ್ಪ್ರಿಂಗ್ ಕಾನ್ಸ್ಟೆಂಟ್ per unit length. So that is your spring constant. ಇದರ ಮೇಲೆ ಸ್ವಲ್ಪ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅನ್ನು ಸಾಲ್ವ್ ಮಾಡೋಣ. ಸೊ here find out the expansion in the spring when the system is in equilibrium. So what is the system? ಇಲ್ಲೊಂದು ಸ್ಪ್ರಿಂಗ್ ಇದೆ, ಅದರ ಸ್ಪ್ರಿಂಗ್ ಕಾನ್ಸ್ಟೆಂಟ್ k is equal to 160 ನ್ಯೂಟನ್ ಅಂತೇಳಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ನ್ಯೂಟನ್ ಪರ್ ಮೀಟರ್ ಅಂತೇಳಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಇದು ನಾನು 8 kg ಬ್ಲಾಕನ್ನು ಹ್ಯಾಂಗ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? ಸೊ 8 kg ಬ್ಲಾಕಿನ ವೆಯ್ಟ್ ಇರೋದ್ರಿಂದ because of this weight, right, because of this 8g weight, this spring will expand, correct? This spring will expand. So this spring will expand. So now this 8 kg mass has come here. So what is the displacement? See, what is the displacement? Spring was here, right? It expanded. So the mass was here, it came here. So this expansion, right? This expansion is your x. This expansion is what we need to calculate. X is the expansion. Whenever there is this much of expansion, so spring, inside spring there will be F, restoring force. So spring will develop restoring force F. But under equilibrium ಅಂದ್ರೆ ಏನು? ಇದರ ಫ್ರೀ ಬಾಡಿ ಡಯಾಗ್ರಾಮ್ನ ಬರೆದ್ರೆ all the forces will balance, right? Under equilibrium net force will be 0, right? Will be 0. So observe here, what are the total forces on 8 kg block, right? Apply NLM to 8 kg. So its own weight is acting downward, right? So 8g and restoring force is acting upwards minus F is, since it is under equilibrium, acceleration will be 0. So F is going to be 8g. But this F is also equal to k into x, right? But this F is also equal to k into x. This F is also equal to k into, right? So this F, restoring force, F is also equal to k into x, right? I'm writing the magnitude, right? This is magnitude I'm writing. Magnitude. Why are we not considering minus sign? ಅದನ್ನ ಕೇಳಬೇಡಿ, ಯಾಕಂದ್ರೆ ಮೈನಸ್ ಸೈನ್ ಅನ್ನ ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಿ ಜಸ್ಟ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಅನ್ನ ಬರಿತಾ ಇದ್ದೀನಿ. ಸೊ ಎಫ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಕೆ ಎಕ್ಸ್ ಅಂಡ್ ಎಫ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 8g. ಸೊ ಐ ಕಂಬೈನ್ ಬೋತ್ ಆಫ್ ದೆಮ್. ಸೊ ಕೆ ಎಕ್ಸ್ is going to be 8g, right? Kx is going to be 8g and x is going to be 8g divided by k. 8 into g is standard value 10, k they have given it as 160. So x is going to be 80 divided by 160. So x is directly 0.5 meter, correct? So x is 0.5 meter. You have the answer 0.5 meter as the expansion in the spring. So e expansion alli the forces will balance, correct? So ಇದು ಕ್ಲಿಯರ್ ಆಯಿತು. ಒಂದು ಸ್ಪ್ರಿಂಗು ಆ ಸ್ಪ್ರಿಂಗಿಗೆ ಮಾಸನ್ನು ಅಟ್ಯಾಚ್ ಮಾಡಿದಾಗ ಈಕ್ವಲಿಬ್ರಿಯಮ್ ಯಾವ ಕಂಡೀಷನಲ್ಲಿರುತ್ತೆ, ರೈಟ್? ರೀಸ್ಟೋರಿಂಗ್ ಫೋರ್ಸ್ ಏನು, ಅದರ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಏನು, ಸ್ಪ್ರಿಂಗ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಏನು, ಎಲ್ಲ ಕ್ಲಿಯರ್ ಆಯಿತು. ಸೊ ಈ ಥರದ್ದು ಒಂದು ಎರಡು ಸ್ಪ್ರಿಂಗನ್ನು ನಾನು ಒಂದು ಸರ್ಟೈನ್ ಕಾಂಬಿನೇಷನಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿದಾಗ ಅದರ ನೆಟ್ ಎಫೆಕ್ಟ್ ಏನಿರುತ್ತೆ, ರೈಟ್? ನೆಟ್ ಸ್ಪ್ರಿಂಗ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಏನಿರುತ್ತೆ ಅದ್ರ ಬಗ್ಗೆ ಸ್ವಲ್ಪ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಸೊ ಕಾಂಬಿನೇಷನ್ ಆಫ್ ಸ್ಪ್ರಿಂಗ್ಸ್, ಯು ಹ್ಯಾವ್, ರೈಟ್, ಡಿಫರೆಂಟ್ ಸ್ಪ್ರಿಂಗ್ಸ್ ಆಫ್ ಸ್ಪ್ರಿಂಗ್ ಕಾನ್ಸ್ಟೆಂಟ್ k1 and k2. So our springs I am connecting in a certain fashion. First time I am connecting in series. Series andre one next to another, right? So you have spring 1 of spring constant k1 connected to spring 2 of spring constant k2. In this case yen ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂದ್ರೆ I am expanding this, right? In that case the displacement in spring 1 is x1, let us say, and displacement in this one is x2, right? So the total displacement is going to be x1 plus x2. The total displacement is x1 plus x2. Total displacement is x1 plus x2. Here this x1 when I applied some force, that restoring force in it, right? That restoring force, which is F, I'm writing x1, that restoring force F1 divided by k1 but with negative sign, that is your x1, and x2 is going to be minus F2 divided by k1. But when I apply external force, same external force ಆಗಿರೋದ್ರಿಂದ these two F and F are going to be same. These two F and F are going to be, F1 and F2 are going to be same. So these two F1 and F2 are going to be same. So ಈ ಎರಡನ್ನ I'm trying to replace it with one spring having spring constant, let us say k equivalent. So this k equivalent has to do same displacement with the same force. In that case here x is going to be minus F divided by x, correct? The minus F divided by k equivalent. Substitute the values here. If you substitute the values, so x1 plus x2 ಗೆ substitute ಮಾಡ್ತಾ ಇದ್ದೀನಿ. So then it is going to be x ಏನಿದೆ minus F by k equivalent, and x1 ಏನಿದೆ minus F by k1, and x2 ಏನಿದೆ minus x by F by k2. So minus F everywhere got cancelled. So here 1 by k equivalent is 1 by k1 plus 1 by k2. Spring constant in series we got, right? The equivalent spring constant in series we got, right? In parallel I'm doing, so in parallel what do? We have a fixed surface, adakke one the spring having spring constant K1, another spring having spring constant K2 ನ ನಾವು ಪ್ಯಾರಲಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿಬಿಟ್ಟು ಒಂದು ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್ ಎಫ್ ಅನ್ನು ಈ ಡೈರೆಕ್ಷನಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಇದನ್ನು ಐ ವಾಂಟ್ ಟು ರೆಪ್ರೆಸೆಂಟ್ ಇಟ್ ವಿತ್ ಈಕ್ವಲೆಂಟ್ ಕಾಂಬಿನೇಷನ್, ರೈಟ್. ಒಂದೇ ಸ್ಪ್ರಿಂಗಲ್ಲಿ ಇದರ ರೈಟ್ ಒಂದೇ ಸ್ಪ್ರಿಂಗಲ್ಲಿ ದ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ದಟ್ ದಿಸ್ ಒನ್ ಹ್ಯಾಸ್ ಡನ್, ರೈಟ್, ಅಂಡರ್ ದ ಸೇಮ್ ಎಫ್ ಎಕ್ಸ್ಟರ್ನಲ್, under the same external should be same. So you have spring having spring constant K equivalent. This has to do the same displacement x and x under the same force, under the same F external, right, under the same F external. See guys, observe here, here your F external has to be restoring force of this one plus this one, then only we can say the body is in equilibrium. So your F1 is going to be K1 into X, F2 is going to be K2 into X. But this F1 restoring force in this one F1 and the restoring force in this one F2, right, they're ulta of displacement. So minus. Similarly here also the same value F is in ulta direction, so minus K equivalent into X. So ಇಲ್ಲಿ ಎಲ್ಲ ಕಡೆ x is getting cancelled and minus is also getting cancelled. So I can write K equivalent is equal to simply K1 plus K2, in parallel, and this one is in series. So ಎರಡು ಸ್ಪ್ರಿಂಗ್ಸ್ ಅನ್ನು ಕೊಟ್ಟು ಆದರೆ K1 K2 ನ ಕೊಟ್ಟು when they are connected in parallel, how do we get you just add the spring constant. When they are connected in series, what do? We use this formula to get the equivalent total value, equivalent value of that spring constant. This is how we calculate. Okay, so that is clear. ಸ್ಪ್ರಿಂಗ್ ಮಾಸ್ ಸಿಸ್ಟಮ್ ಬಗ್ಗೆ, ಸ್ಟ್ರಿಂಗ್ ಮಾಸ್ ಸಿಸ್ಟಮ್ ಬಗ್ಗೆ ಎಲ್ಲ ಕ್ಲಿಯರ್ ಆಯಿತು. ಸೊ ಸೂಡೋ ಫೋರ್ಸ್ ಅನ್ನೋ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಬಗ್ಗೆ ನೋಡೋಣ. ಸೂಡೋ ಫೋರ್ಸ್ ಅಂದರೆ ಏನು ಅಂತ ಹೇಳ್ತೀನಿ. ಸಿ, ವೆನೆವರ್ ದೇರ್ ಇಸ್ ಅ ಪರ್ಸನ್, ರೈಟ್, ಆ ಪರ್ಸನ್ ಇಸ್ ದೇರ್, I call him as person 1, right. Person 1, what is he doing? Is in the lift, right, is in the lift which is going up, right. He's sitting in a lift which is going up. What is he doing? He's looking at this block. ಈ ಬ್ಲಾಕ್ ಅನ್ನ ನೋಡ್ತಾ ಇದ್ದಾನೆ. ಸೊ ಈ ಬ್ಲಾಕ್ ಮೇಲೆ ಆಕ್ಟ್ ಆಗ್ತಾ ಇರೋ ಫೋರ್ಸಸ್ ಏನು? ಅಕಾರ್ಡಿಂಗ್ ಟು mg, ರೈಟ್, ಅಕಾರ್ಡಿಂಗ್ ಟು mg, ಅಂಡ್ ನಾರ್ಮಲ್ ಫೋರ್ಸ್ ಏನಿದೆ ಅಪ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಇದೆ. ಸೊ ಅಕಾರ್ಡಿಂಗ್ ಟು ದಿಸ್ ಗಾಯ್, according to observer 1, right, observer 1, this m is in equilibrium, but there is no way that he knows. ಇವನಿಗೆ ಗೊತ್ತಿಲ್ಲ ಈ ಲಿಫ್ಟ್ ಆಕ್ಸಿಲರೇಟ್ ಆಗ್ತಾ ಇದೆ ಮೇಲೆ ಅನ್ನೋದು ಗೊತ್ತಿಲ್ಲ, ಯಾಕಂದ್ರೆ ಈಸ್ ಇನ್ಸೈಡ್ ದ ಲಿಫ್ಟ್, ರೈಟ್. ಸೊ ಈಸ್ ಸಿಟ್ಟಿಂಗ್ ಇನ್ಸೈಡ್ ದ ಲಿಫ್ಟ್. ಸೊ ಅಕಾರ್ಡಿಂಗ್ ಟು ಅಬ್ಸರ್ವರ್ 1, the block m is in equilibrium, right. So avun prakara m is in equilibrium allide. So he says that n is equal to mg. Total forces on the body are balanced, so n is equal to mg. But when I take an observer 2 on the ground, is on the ground. So he is on the ground. According to this guy, the lift is going up, right. You can see that the lift is going up. Block kuda mele hogta ide. According to him, ee block is not in equilibrium, right. So according to observer 2, m is accelerating. So E applies NLM. Since the block is going up, n minus n minus mg has to be equal to mass into acceleration, right? This block is going up, the block inside the lift is also going up, no? So this you can see. So he says that n minus mg is equal to ma. According to him, n is mg plus ma. N is mg plus ma, right? N is mg plus ma. These two are contradictory result, right? Observed 1 reading and observed 2 reading. O1's reading, O1 reading and O2 reading are not matching, right? Are not matching. Then who is right? Who is right? Then who is right? So who is right? That is the question I ask you. Who is right? Think about it. A1, observer 1 does not know the lift is accelerating because he is sitting or he is observing inside the lift. According to him, block is in equilibrium. But observer 2 has seen clearly that the object is going up, correct? He has to apply NLM. According to him, N is this, correct? Then who is right? Clearly, whoever observed everything clearly, that is observer 2 is right. So this observer 1 is wrong, but observer 1 is wrong. Observer 1 is wrong. But how do we make correction? How do we make correction? That making correction is where the pseudo force concept comes in. Pseudo force, right? Pseudo force is used to, right, correct the calculations in accelerating frame, that can be done by considering including pseudo force. Pseudo force means a fictitious force, non-real force. Pseudo force means a fictitious force or a non-real force. A fictitious force or not real. This is not real because we are applying it to make the problem correct. So to make the problem correct, that can be done by including the pseudo force in the direction opposite to acceleration, with magnitude m into a. So ಏನು ಮಾಡಬೇಕು, ಈ ತರ ಕಂಡೀಷನ್ ಅಲ್ಲಿ pseudo force ಅನ್ನು ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬೇಕು. Pseudo force should be in the direction opposite to acceleration of the force. This fs should be equal to m a. Now observe, now include pseudo force and try to solve the problem according to this O1 guy, observer 1 guy. There is mg acting downwards, capital M into g acting downwards. There is pseudo force acting downwards and net normal reaction force acting upwards, right? Still, according to him, the block is ಏನಲ್ಲಿದೆ, equilibrium allide, but we are considering one extra force, that is pseudo force opposite to acceleration of the frame. So according to observer 1, m is in equilibrium, but we are including pseudo force this time, right? So your n is going to be equal to, upward force is n, there are two downward force now. One is real weight, another one is pseudo non-real, that is your pseudo force. So m into g plus m into g, right? This is capital M. Okay, both of them are capital. Okay, don't get confused. This is capital M into A. So m into g plus m into A, right? Now go back and see. Now go back and see. This is in accordance with observer 2. So observer 2 and observer 1 reading are matching. Now this is correct. Now this is correct. Now this is correct. Now this is correct, right? According to O1, n is equal to mg plus ma. According to observer 2, n is equal to mg plus ma, right? See, this is a general observation. Now lift al male hogta iruvaga, we feel like our weight has increased, right? When we go down, we feel like the weight has reduced. So accelerate male aagta idivi andre, so our weight, extra weight is given by that acceleration of the lift times the mass we have. So that is where pseudo force concept comes into picture. We can directly solve from the ground frame only, right? Without O1, O1 ಯಾರು ಹೇಳಿದ್ರು ಲೆಕ್ಕ ಮಾಡು ಅಂತ, ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಬೇಕಾಗಿಲ್ಲ O1. ಸೊ ಗ್ರೌಂಡ್ ಫ್ರೇಮ್ ಇಂದ ವಿ ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ಎವ್ರಿಥಿಂಗ್ ಅಂಡ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಇಟ್ ಕರೆಕ್ಟ್ಲಿ. ಬಟ್ ಇನ್ ಕೇಸ್ ವಿ ವಾಂಟ್ ಟು ಸಾಲ್ವ್ ಫ್ರಮ್ accelerating frame or sitting inside the lift, in that case we need to calculate or we need to include pseudo force ಅನ್ನು ನಾವು ಇನ್ಕ್ಲೂಡ್ ಮಾಡ್ಕೊಳ್ಳೇಬೇಕು. ಇಲ್ಲ ಅಂದರೆ ಪ್ರಾಬ್ಲಮ್ ತಪ್ಪಾಗುತ್ತೆ. ಆಕ್ಸಿಲರೇಟಿಂಗ್ ಫ್ರೇಮಲ್ಲಿ ನಾವು ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಅಂದರೆ pseudo force ಇಲ್ಲ ಅಂದರೆ ಪ್ರಾಬ್ಲಮ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ರಾಂಗ್. ಸೊ ದೀಸ್ ಆರ್ ದ ಕೇಸಸ್ ವೆನ್ pseudo force ಕ್ಯಾನ್ ಬಿ ಯೂಸ್. ಸೊ ಲಿಫ್ಟ್ ಫ್ರೇಮ್ ಮತ್ತು ಗ್ರೌಂಡ್ ಫ್ರೇಮ್ ಎರಡನ್ನೂ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಒಂದು ಪ್ರಾಬ್ಲಮನ್ನು ಸಾಲ್ವ್ ಮಾಡೋಣ. ಎ ಬ್ಲಾಕ್ ಆಫ್ ಎಮ್, ಮಾಸ್ ಎಮ್, ದೇರ್ ಇಸ್ ಅ ಬ್ಲಾಕ್ ಆಫ್ ಮಾಸ್ ಎಮ್, right? This exerts a force mg by 4 on the floor. So in reaction to that, this floor will also exert the same force in opposite direction, right? This normal is mg by 4 exerts a force on the floor. So the floor will also exert force on the block. That normal reaction is mg by 4. So what is the acceleration of the container? So we need to calculate what is this acceleration of the container. What is this A going to be? So according to ground frame, first ground frame alli solve madona, right? According to ground frame, see, according to ground frame, what are the forces? mg is acting down. According to ground frame, mg is acting down, right? And this n is acting up, right? And this m is accelerating downward. So according to ground frame, mg minus n is equal to m into a, correct? And this n is given as mg by 4. So mg minus mg by 4, which is equal to m into a. So mg minus mg by 4, 3mg by 4, but mm gets cancelled. So a is going to be directly 3g by 4. But when I solve from accelerating frame R, right? So this one we solved from ground frame, right? This is G frame. But if I want to solve from lift frame, lift alle oba observer observe ಮಾಡ್ತಾ ಇದ್ದಾನೆ ಅಂದರೆ, ರೈಟ್, ಆಗ ಏನು ಮಾಡಬೇಕು, ನಾವು ಸೂಡೋ ಫೋರ್ಸನ್ನು ಅಪ್ಲೈ ಮಾಡಬೇಕಾಗತ್ತೆ. ಸೊ ಲಿಫ್ಟಲ್ಲಿ ಒಬ್ಬ ಅಬ್ಸರ್ವರ್ ಇದ್ದಾನೆ ಅಂದರೆ, ಸೊ ಲಿಫ್ಟ್ ಫ್ರೇಮಲ್ಲಿ ಅಬ್ಸರ್ವರ್ ಇದ್ದಾನೆ ಅಂದರೆ, ಇನ್ ದಟ್ ಕೇಸ್ ವಿ ನೀಡ್ ಟು ಅಪ್ಲೈ ಸೂಡೋ ಫೋರ್ಸ್. ಈ ಪ್ರಾಬ್ಲಮಲ್ಲಿ ಸೂಡೋ ಫೋರ್ಸನ್ನು ಅಪ್ಲೈ ಮಾಡಿ ಸಾಲ್ವ್ ಮಾಡೋಣ. ಸೊ ರೈಟ್, ವಿ ಹ್ಯಾವ್ pseudo force. So lift frame ಅಲ್ಲಿ, ಸೊ ಒಂದು ಡಬ್ಬ ಇದೆ, ಆ ಡಬ್ಬ is accelerating downwards. This acceleration we need to find. So there is a person inside, right? He is looking at the block. They are saying that this normal reaction is mg by 4. This normal reaction is mg by 4, and according to him weight is acting downwards, mg. But we need to include what type of force? We need to include pseudo force also, pseudo force also on the block, pseudo force also on the block. So this pseudo force whose magnitude is mass into acceleration of the frame, mass into acceleration of the frame. So after including pseudo force equate the forces, as seen by observer in the lift, as seen by the observer in the lift, because according to him the body is in equilibrium, but we included pseudo force na consider ಮಾಡ್ಕೊಂತಾ ಇದೀವಿ. So mg plus right, mg plus pseudo force which is fs equal to normal reaction, right, normal reaction. mg pseudo force ಏನಿದೆ m into a, and this one is mg by 4. So mg by 4. So mg plus, no, what is the mistake? That pseudo force, this pseudo force has to be opposite to the direction of acceleration. So pseudo force is going to be in this direction. fs is m into a in the opposite directions, correct? So then I can rewrite this expression as mg equal to n plus pseudo force, right? mg n ಏನಿದೆ ಕೊಟ್ಟಿದ್ದಾರೆ ಡೈರೆಕ್ಟ್ಲಿ mg by 4, fs m into a. So ಈ mg by 4 ನ ಈ ಕಡೆ ತರ್ತೀನಿ. So ma is going to be 3mg by 4 or acceleration is going to be 3g by 4. Answer different ಬರಲ್ಲ, answer will be same, but if you are looking at an accelerating frame and solving the problems, you need to include that pseudo force opposite to the direction of acceleration of the frame, right? Acceleration of the frame. So this concept of pseudo force will come in your JEE mains or advanced problems. These type of concepts have to be cleared and practiced enough. You have to practice lot. So practice ಮಾಡಿದ್ರೆ ಮಾತ್ರ ಈ ತರದ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡೋಕ್ಕೆ ಸಾಧ್ಯ. ಸೊ ಇಲ್ಲಿ ತನಕ ಎಲ್ಲ ಪ್ರಾಬ್ಲಮ್ಸ್ ರಿಲೇಟೆಡ್ ಟು ನ್ಯೂಟನ್ ಲಾಸ್ ಆಫ್ ಮೋಷನ್ನ ನಾವು ಸಾಲ್ವ್ ಮಾಡಿದ್ದೀವಿ, ಬಟ್ ವಿತೌಟ್ ಇನ್ಕ್ಲೂಡಿಂಗ್ ಫ್ರಿಕ್ಷನ್, ರೈಟ್? ಸೊ ಎಲ್ಲ ಸರ್ಫೇಸ್, ವಾಟ್ ಆರ್ ದ ಸರ್ಫೇಸಸ್ on the block moving, we said all those surfaces are smooth, but in reality that is not true alva. So friction irutte, ನಾನು ಒಂದು ಬ್ಲಾಕ್ ಅನ್ನು ಮೂವ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ there is an opposition, right? It's not easy to start the motion quickly, so that opposition we call it as friction. So friction in general is called as opposition to the relative slipping between surfaces between surfaces, right? So ಒಂದು ಬ್ಲಾಕ್ ಇದೆ, ಇದರ ಮೇಲೆ ನಾನು ಒಂದು ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸನ್ನು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಎಫ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸನ್ನು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಒಂದು ಎಫ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸನ್ನು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂದರೆ, ಒಂದು ಸ್ಮಾಲ್ ಅಮೌಂಟ್ ಆಫ್ ಎಫ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂದರೆ ಬಾಡಿ ವಿಲ್ ನಾಟ್ ಇಮಿಡಿಯೇಟ್ಲಿ ಮೂವ್, ರೈಟ್? ಸೊ ಅಪ್ಲೈ ಮಾಡಿದೆ, ಸ್ಮಾಲ್ ಅಮೌಂಟ್ ಆಫ್ ಫೋರ್ಸನ್ನು ಅಪ್ಲೈ ಮಾಡಿದೆ, ಮೂವ್ ಆಗ್ತಾ ಇಲ್ಲ. ಐ ಇನ್ಕ್ರೀಸ್ ಮೈ ಫೋರ್ಸ್, ಇನ್ನೂ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಎಳಿತಾ ಇದ್ದೀನಿ, ಅವಾಗೂ ಕೂಡ ಬರ್ತಾ ಇಲ್ಲ. ಇನ್ನೂ ಸ್ವಲ್ಪ ಫೋರ್ಸನ್ನು ನಾನು ಹಾಕ್ತಾ ಇದ್ದೀನಿ, ಬ್ಲಾಕ್ ಬರ್ತಾ ಇಲ್ಲ, ರೈಟ್? ಸೊ there has to be somebody who is opposing this motion, right? So that force is what we call as friction. That force is what we call as friction, right? This force is what we call as friction. This is a force. This force is electromagnetic in nature. This friction, the origin of friction is the electromagnetic interaction between the two surfaces in contact. So this friction is magnetic in nature. Magnetic in nature. So whenever whenever we have two surfaces in contact, so because of the contact between the surfaces, ಒಂದು contact force ಇರುತ್ತೆ. So this contact force is what we call as R. So here R is contact force. Contact force due to the two surfaces in contact. So friction, what we call as, is one of the horizontal component. Friction is a horizontal component. Friction is this friction F, we represent by letter F. Friction is the horizontal component of R. ಈ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ನ ಹಾರಿಜಾಂಟಲ್ ಕಾಂಪೊನೆಂಟ್ನ ನಾವು ಫ್ರಿಕ್ಷನ್ ಅಂತ ಕರಿತೇವೆ. ಸೊ ವರ್ಟಿಕಲ್ ಕಾಂಪೊನೆಂಟನ್ನು ನಾವು ಎನ್ ಅಂತೇಳಿ ಕರಿತೇವೆ, ವರ್ಟಿಕಲ್ ಕಾಂಪೊನೆಂಟನ್ನು ಎನ್ ಅಂತ ಕರಿತೇವೆ. ಬಟ್ ವಿ ಓನ್ಲಿ ಕೇರ್ ಅಬೌಟ್ ಫ್ರಿಕ್ಷನ್ ಆಸ್ ಆಫ್ ನೌ. ಸೊ ವಿ ಓನ್ಲಿ ಲುಕ್ ಅಟ್ ದ ಫ್ರಿಕ್ಷನ್ ಅಂಡ್ ಇಟ್ಸ್ ಟೈಪ್ಸ್, ರೈಟ್? ಬಿಕಾಸ್ ವೆನ್ ಐ push, initially try to pull the block, right? It is difficult to start the motion, but when the motion is happening, nanu force apply madilla to keep the motion andre, so it will come to rest. So ಒಂದು ಬ್ಲಾಕ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ, ಅದ್ರ ಮೇಲೆ ಯಾವುದೇ ರೀತಿ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇಲ್ಲ, ತನ್ನಷ್ಟಕ್ಕೆ ತಾನೇ ದಟ್ ವಿಲ್ ಕಮ್ ಟು ರೆಸ್ಟ್, ರೈಟ್? ಸೊ ಯಾವುದೇ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿಲ್ಲ ಅಂದರೆ ಐ ಆಮ್ ನಾಟ್ ಏಬಲ್ ಟು ಸ್ಟಾರ್ಟ್ ದ ಮೋಷನ್. ಯಾವುದೇ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿಲ್ಲ ಅಂದರೆ ಐ ಆಮ್ ನಾಟ್ ಏಬಲ್ ಟು ಕೀಪ್ ದ ಮೋಷನ್ ಗೋಯಿಂಗ್. ಸೊ ದೇರ್ ಆರ್ ಟೂ ಟೈಪ್ಸ್ ಆಫ್ ಫ್ರಿಕ್ಷನ್. ಸೊ one is static friction, another one we call as kinetic static friction, another one we call as kinetic friction. Kinetic friction. Static friction andre ಏನು? See, I told you the block is at rest on a rough surface. ನಾವು ಅದನ್ನು ಮೂವ್ ಮಾಡಬೇಕು ಅಂದರೆ ಸ್ವಲ್ಪ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಐ ಆಮ್ ನಾಟ್ ಏಬಲ್ ಟು ಮೂವ್ ದ ಬ್ಲಾಕ್. ಇನ್ನೂ ಸ್ವಲ್ಪ ನನ್ನ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸನ್ನು ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದಾಗ ಐ ಆಮ್ ನಾಟ್ ಏಬಲ್ ಟು ಮೂವ್. ಅಟ್ ಸಮ್ ಪಾಯಿಂಟ್ ಆಫ್ ಟೈಮ್, ಒಂದು ಟೈಮಲ್ಲಿ ಐ ಆಮ್ ಏಬಲ್ ಟು ಮೂವ್ ದ ಬ್ಲಾಕ್, ರೈಟ್? ಸೊ ದಿ ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಇಸ್ ದೇರ್ ವೆನೆವರ್ ದೇರ್ ಇಸ್ ಅ ಟೆಂಡೆನ್ಸಿ ಆಫ್ ರಿಲೇಟಿವ್ ಮೋಷನ್. ಮೋಷನ್ ಆಗ್ತಾ ಇಲ್ಲ, although I am applying force, the block is not moving, but there is a tendency of motion, tendency of relative slipping. In that case, there is a friction acting between the surfaces. That friction ಅನ್ನು ನಾವು static friction between the two surfaces ಅಂತೇಳಿ ಕರಿತೇವೆ. ಸೊ ಈ static friction ಅನ್ನು FS ಇಂದ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. FS is static friction, and it is adjusting in nature, self-adjusting in nature. Self-adjusting in nature. ಯಾಕಂದರೆ ಎಫ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಸ್ಮಾಲ್ ಇದ್ದಾಗ ಮೂವ್ ಆಗ್ತಾ ಇಲ್ಲ, ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದಾಗೂ ಕೂಡ ಮೂವ್ ಆಗ್ತಾ ಇಲ್ಲ. ಸೊ ದಿಸ್ ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಮಸ್ಟ್ ಹ್ಯಾವ್ ಇನ್ಕ್ರೀಸ್ಡ್, ರೈಟ್? ಸೊ ದಿಸ್ ಮಸ್ಟ್ ಹ್ಯಾವ್ ಇನ್ಕ್ರೀಸ್ಡ್. ಸೊ ಇಟ್ ಈಸ್ ಅಡ್ಜಸ್ಟಿಂಗ್ ಬೈ ಇಟ್ ಸೆಲ್ಫ್. ಸೊ ಅಂಡ್ ಇಟ್ಸ್ ಲಿಮಿಟ್, ರೈಟ್? Its limit, it goes from 0 to the maximum value, it goes from 0 to the maximum value. So that maximum value we call as FS max. FS max, correct? Here kinetic friction ಅನ್ನು ನಾವು FK ಇಂದ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೇವೆ. kinetic friction ಅನ್ನು ನಾವು FK ಇಂದ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೇವೆ. kinetic friction ಅಂದ್ರೆ ಏನು? ಒಂದು ಬ್ಲಾಕ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ, ರೈಟ್? there is no external force on a rough surface, eventually it comes to rest. So to comes to rest andre, so there has to be somebody opposing the motion. So the friction which acts when there is a relative slipping between the surfaces. ಒಂದರ ಮೇಲೆ ಇನ್ನೊಂದು ಸ್ಲಿಪ್ ಆಗ್ತಾ ಇರೋವಾಗ ಆಕ್ಟ್ ಆಗ್ತಾ ಇರೋ ಫ್ರಿಕ್ಷನ್ ನಾವು ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಅಂತ ಹೇಳಿ ಕರಿತೇವೆ. ಸೊ ದಿಸ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್, it is not self-adjusting, it has a definite value. This has a definite value. This has a definite value. This one we say mu k into n. This one we say goes from 0 to 0 to 0 to 0 to mu s into n. Correct? So ಇದರ ರೇಂಜು 0 ಇಂದ mu s into n ಇರುತ್ತೆ. ಇದರ ವ್ಯಾಲ್ಯೂ mu k into n ಇರುತ್ತೆ. Here what are mu s? Mu s and mu k. Mu k is coefficient of kinetic friction and mu n is coefficient of static friction. Coefficient of static friction, and mu k is coefficient of kinetic friction. Coefficient of kinetic friction. So the minimum value of Fs is 0. Maximum value of Fs ಏನಿರುತ್ತೆ ಅಂದರೆ mu s into n. What is this n? Normal reaction between the surfaces. This definite value of Fk is definite, will be equal to mu k into n. So this Fs maximum value is what we call as limiting value of static friction, above which static friction cannot go. In that case, external force more than the limiting value of static friction ide andre external force can cause motion. In that case, static friction can no longer further increase. Correct? So kinetic friction is mu k into n. The maximum value of static friction is Fs is mu s into n. So idra mele swalpa problems anna solve ಮಾಡೋಣ. Problem solve ಮಾಡಿದ್ರೆ ಕಂಪ್ಲೀಟ್ ಕ್ಲಾರಿಟಿ ಬರುತ್ತೆ. ಬಿಫೋರ್ ದಟ್ ವೇರಿಯೇಷನ್ ನಾನು ಒಂದ್ಸಲಿ ತೋರಿಸ್ತೀನಿ. ಸೊ ವೇರಿಯೇಷನ್ ಆಫ್ ಫ್ರಿಕ್ಷನ್ ವಿತ್ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್. ಸೊ ಒಂದು ಬ್ಲಾಕ್ ಇದೆ, ರೈಟ್, ಒಂದು ಬ್ಲಾಕ್ ಅನ್ನೋ ಸರ್ಫೇಸ್ ಇದೆ. ಸೊ ಇದರ ಮೇಲೆ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್ ಎಫ್ ಇದೆ, ರೈಟ್. ಸೊ ಈ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್ 0 ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, 0 ನ್ಯೂಟನ್ ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ರೈಟ್. ಬ್ಲಾಕ್ ಮೂವ್ ಆಗ್ತಾ ಇಲ್ಲ, ಯಾಕಂದರೆ ಸ್ಟಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಇಸ್ ಆ್ಯಕ್ಟಿಂಗ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್. But at a maximum value of F external, at a particular value of F external, this block will start to move, right? So I'm applying F external, block is not moving, so block is not moving till a minimum value of F external. But after which the block starts to move. And this kinetic friction has a definite value, right? So this kinetic friction has a definite value. So this definite value, how do we get? I told you mu k into n, correct? But this maximum value of static friction, right? This maximum value of static friction is mu s into n. This Fs has a range 0 to mu s into n, but Fk has a definite value mu k into n. But why is there a reduction in friction? Why is there a reduction in friction? We say this is because it is easy to keep motion going than starting. ಒಂದು ಬ್ಲಾಕ್ ಅನ್ನ ಮೋಷನ್ ತರೋದು ಕಷ್ಟ ದ್ಯಾನ್ ಕೀಪಿಂಗ್ ಇಟ್, ರೈಟ್. ಒಂದು ಬ್ಲಾಕ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಯು ಕ್ಯಾನ್ ಕೀಪ್ ಇಟ್ ಪುಲ್ಲಿಂಗ್, ರೈಟ್, ವಿತ್ ಲೀಸ್ಟ್ ಅಮೌಂಟ್ ಆಫ್ ಫೋರ್ಸ್ ದ್ಯಾನ್ ಗೆಟಿಂಗ್ ಇಟ್ ಟು ಮೋಷನ್. ದಟ್ ಈಸ್ ವೈ kinetic friction value will be lesser than static friction's maximum value in general. So in general mu k will be lesser than mu s. Mu k will be lesser than mu s. But if mu k mu s values are not separately given andre we can treat mu k mu s both are equal ಅಂತೇಳಿ ನಾವು ತಗೊಂಡು ಪ್ರಾಬ್ಲಮ್ಸ್ ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು, ಕರೆಕ್ಟ್. ಸೊ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್ ಜಾಸ್ತಿ ಮಾಡಿದಾಗೆ ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ ಟು ಅ ಸರ್ಟೈನ್ ವ್ಯಾಲ್ಯೂ, ರೈಟ್. ಒನ್ಸ್ your applied force has reached mu s into n, static friction will ceases, the body ಏನಾಗುತ್ತೆ ಮೂವ್ ಆಗೋಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಮೂವ್ ಆದಾಗ ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಆಕ್ಟ್ ಆಗುತ್ತೆ ಇನ್ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಟು ದ ಮೋಷನ್. ಸೊ ದಟ್ ಆಸ್ ಅ ಡೆಫಿನೆಟ್ ವ್ಯಾಲ್ಯೂ mu k into n. So mu k into n, this kinetic friction value is mu k into n. Clear? ಇದರ ಮೇಲೆ ಕೆಲವಷ್ಟು ಪ್ರಾಬ್ಲಮ್ ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡೋಣ. ಸೊ ಕೆಲವಷ್ಟು ಪ್ರಾಬ್ಲಮ್ ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡೋಣ. ಸಿ ಅಬ್ಸರ್ವ್ ಹಿಯರ್, there's a 1 kg block, right? There's a 1 kg block here. Coefficient of static friction 0.5 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, coefficient of kinetic friction 0.4 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಡಿಫರೆಂಟ್ ವ್ಯಾಲ್ಯೂಸ್ ಆಫ್ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್. ಇದರ ಮೇಲೆ ಎಫ್ ಎಕ್ಸ್ಟರ್ನಲ್, ರೈಟ್, ಒಂದು ಫೋರ್ಸನ್ನು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಇಟ್ ಹ್ಯಾಸ್ ಅ ಡಿಫರೆಂಟ್ ವ್ಯಾಲ್ಯೂ, 1 Newton, 2 Newton, 3 Newton, 4 Newton, like this. So you need to calculate the frictional force acting on this one. What type of frictional force it is and what is the value of that frictional force ಎಲ್ಲದನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಹೋಗೋಣ. ಸೊ 1 Newton ಫೋರ್ಸನ್ನು ನಾನು ಅಪ್ಲೈ ಮಾಡಿದಾಗ is the block going to move? So let us observe. For that, in all the types of friction problems ಅಲ್ಲಿ ಯಾವಾಗ ಬ್ಲಾಕ್ ಮೂವ್ ಆಗುತ್ತೆ ಅನ್ನೋದು ನನಗೆ ಗೊತ್ತಿರಬೇಕು. ಯಾವಾಗ ಮೂವ್ ಆಗುತ್ತೆ? ಯಾವಾಗ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್ ಇಸ್ ಮೋರ್ ದೆನ್ the limiting value of static friction. So we need that limiting value of static friction. So Fs max is, how do we calculate Fs max? Fs max is mu s into n, correct? But in y direction ಅಲ್ಲಿ ಬ್ಲಾಕ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ we can say n is equal to m into g. So n equal to m into g. So this Fs max, which is mu s m into g, right? M into g. What is the value going to be? Mu s is 0.5, m is 1 kg, m is 1 kg, and g is 10. So Fs max is 10 into 0.5, which is 5 Newton, right? So Fs max 5 Newton ಇರೋದ್ರಿಂದ 5 Newton, more than 5 Newton ಅಪ್ಲೈ ಮಾಡೋ ತನಕ ಬ್ಲಾಕ್ ವಿಲ್ ನಾಟ್ ಮೂವ್, ಕರೆಕ್ಟ್. ಬಟ್ 1 Newton ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಇರುತ್ತೆ, 1 Newton ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಇರುತ್ತೆ ಇನ್ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್, ಬಟ್ ದಟ್ ಈಸ್ ಆಫ್ ದ ನೇಚರ್ ಎಫ್ ಎಸ್, ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್. ಸೊ ದಿಸ್ ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಈಸ್ 1 Newton. Acceleration will be zero because this one will cancel this one. 2 Newton ಅಪ್ಲೈ ಮಾಡಿದಾಗ still this 2 Newton is less than 5 Newton, so is going to be 2 Newton, but the nature is static friction, acceleration is 0. 3 Newton ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಕೂಡ ಬ್ಲಾಕ್ ಮೂವ್ ಆಗಲ್ಲ. ಸೊ ಬಟ್ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಏನಿರುತ್ತೆ 3 Newton ಇರುತ್ತೆ, ಬಟ್ ಇಟ್ ಇಸ್ ನೇಚರ್ ಏನಿರುತ್ತೆ ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್, acceleration is still 0. 4 Newton ಅನ್ನು ಅಪ್ಲೈ ಮಾಡ್ತೀನಿ, ಬ್ಲಾಕ್ ಮೂವ್ ಆಗಲ್ಲ, ಬಟ್ ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಇನ್ ನೇಚರ್ is 0. 5 Newton ಅನ್ನು ಅಪ್ಲೈ ಮಾಡ್ತೀನಿ, ಬ್ಲಾಕ್ just starts to move, which means the block is about to have acceleration. It is not moving, just forces are balance agide, correct? In that case, nature of friction is still static. Friction is at its maximum value, right? In that case, friction nature ಏನಿರುತ್ತೆ static and acceleration is still 0. Block is about to move, which means tendency of motion is there, alva? Tendency of motion is there, but the motion is not happening. That is why friction nature ಏನಿದೆ static ಇದೆ, acceleration still 0 ಇದೆ. But applied for 6 Newton ಆದಾಗ, 6 Newton ಆದಾಗ, applied for 6 Newton ಆದಾಗ, that 6 Newton is more than static friction's key maximum value. So the block will move. The block will move. But in this case, nature of friction ಏನಿರುತ್ತೆ, kinetic friction ಇರುತ್ತೆ. This kinetic friction value is mu k into n. This kinetic friction value is mu k into n. See, Fs, here I am writing Fs range goes from 0 to Fs, right, max. But Fk is just mu k into n. This Fs max is directly mu s into n, right? We have that Fs max mu s into n. No need to write one more time. So here Fk is going to be mu k into n. Mu k ಏನಿದೆ 0.4 ಇದೆ. 0.4 into n ಏನಿದೆ m into g, which is 10. So in this case, Fk, one more time, Fk is mu k into n. Mu k ಏನಿದೆ 0.4, n ಏನಿದೆ 1 into 10, which is 10. So Fk is 4 Newton. So applied force 6 Newton ಇದೆ, opposing force 4 Newton ಇದೆ. Acceleration is going to be 6 minus 4 divided by mass 1. So acceleration is going to be 2 meter per second square. Friction 2 meter per second square acceleration na try to reduce ಮಾಡ್ತಾ ಇದೆ, right? Try to reduce ಮಾಡ್ತಾ ಇದೆ. But when you have 7 Newton of applied force, 7 Newton of applied force, this 7 is greater than this 5. Definitely block is having kinetic friction ಇದೆ, but ಅದರ value Fk is going to be mu k into n. Again, I told you kinetic friction will have definite value. Still, this is 4 Newton, but acceleration ಏನಿರುತ್ತೆ 7 minus 4 divided by 1 mass, which is 3 meter per second square, correct? So I hope you are clear with static friction ಯಾವ ತರ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ, kinetic friction ಯಾವ ತರ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ, ಎಲ್ಲಿ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ. Kinetic friction value constant ಇದೆ, static friction value kept on increasing. At maximum value it will not further increase. Who comes into picture? Kinetic friction ಬರುತ್ತೆ ಆ ಕೇಸಲ್ಲಿ, right? So 2 more problems ಇದರ ಮೇಲೆ ಸಿಂಪಲ್ ಆಗಿ ಸಾಲ್ವ್ ಮಾಡೋಣ. I hope you are getting complete clarity. So a force of 16 Newton, right? They are saying there is a force of 16 Newton applied on the block of mass 2 kg. There's a 2 kg block. Find the frictional force on the block. See, find the frictional force on the block and also acceleration. First of all, acceleration ಇದೆಯೋ ಇಲ್ವೋ ಅಂತ ಗೊತ್ತಾಗಬೇಕು ಅಂದ್ರೆ ಯಾವ ತರದ ಮೋಷನ್ ಆಗ್ತಾ ಇದೆ ಅನ್ನೋದು ಕ್ಲಾರಿಟಿ ಇರಬೇಕು. ಫಸ್ಟ್ ಆಫ್ ಆಲ್, ಇನ್ ಆಲ್ ದೀಸ್ ಟೈಪ್ ಆಫ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ನಾವು ಫಸ್ಟ್ ಏನನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂದರೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ Fs max, because only then I will know whether applied force is more than or less than this maximum value, right? So applied force Fs max ಗಿಂತ ಜಾಸ್ತಿ ಇತ್ತು ಅಂದರೆ ಆಕ್ಸಿಲರೇಷನ್ ಇರುತ್ತೆ, ಅಥವಾ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್ Fs max ಗಿಂತ ಕಡಿಮೆ ಇತ್ತು ಅಂದರೆ ಆಕ್ಸಿಲರೇಷನ್ ಇರಲ್ಲ. ಯಾಕಂದರೆ ಫ್ರಿಕ್ಷನ್ ಇಸ್ ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಇಸ್ ಸೆಲ್ಫ್ ಅಡ್ಜಸ್ಟಿಂಗ್. ಸೊ ದಿಸ್ Fs max is going to be mu s into n. ಸೊ mu s is given as ಏನು ಕೊಟ್ಟಿಲ್ಲ, mu s ಅಥವಾ mu k ಅಂತ ಏನು ಕೊಟ್ಟಿಲ್ಲ. ಇನ್ ದಟ್ ಕೇಸ್ ಐ ಕ್ಯಾನ್ ಟ್ರೀಟ್ mu s equal to mu k. I can treat mu s equal to mu k, right? I can treat mu s equal to mu k when mu value is not separately given. ಇಲ್ಲಿ mu s ಯಾವುದು mu k ಯಾವುದು ಅಂತ ಕೊಟ್ಟಿಲ್ಲ, ಆವಾಗ mu s ಮತ್ತು mu k ಎರಡು ಒಂದೇ ಅಂತೇಳಿ ನಾನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬಹುದು. ಸೊ mu s into n. But what is n? N is the normal reaction which is balancing the weight, which is 2 into 10. Correct? So this n is 2 into 10, which is 20 Newton. So n is 20 Newton. Correct? So n is 20 Newton agiradrinda. So why? Because I'm not writing everything in y direction. In y direction ಏನಾಗ್ತಾ ಇದೆ, ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಅಲ್ಲಿ ಇದೆ, ಬ್ಲಾಕ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಅಲ್ಲಿ ಇದೆ. ಸೊ in y direction n is equal to mg. This mg is 20 Newton. So this 20 Newton na ಇಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡ್ತೀನಿ. mu s ಏನಿದೆ 0.6 into 20. So 0.6 into 20 is going to be 12 Newton. So clearly applied force F external is greater than Fs max. So what type of friction will act? So Fk will act. So here the friction which is acting is Fk, whose value is mu k into n. So since mu k and mu s both are same irodrinda, we can write Fk is mu k into n. 0.6 into n ಏನಿದೆ 20 ಇದೆ. ಸೊ ಇಟ್ ಈಸ್ ಆಲ್ಸೋ 12 ನ್ಯೂಟನ್. ಸೊ ಆಕ್ಸಿಲರೇಷನ್ ನಾವು ಯಾವ ಥರ ಬರಿತೀವಿ? ಅಪ್ಲೈ NLM on the block now. Apply NLM. F external 16 ಇದೆ, right? F minus Fk is equal to mass into acceleration. Correct? So F minus Fk is equal to mass into acceleration in x direction. y direction ಅಲ್ಲಿ ಏನಾಗಿದೆ, ಬ್ಲಾಕ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಅಲ್ಲಿ ಇದೆ. ಸೊ F external 16 minus Fk is 12. ಮಾಸ್ ಏನಿದೆ 2 kg ಇದೆ, ಆಕ್ಸಿಲರೇಷನ್ ಗೊತ್ತಿಲ್ಲ. ಸೊ 16 minus 12 is 4. So 2 into a. So acceleration is going to be 2 meter per second square. Acceleration, we calculated acceleration as 2 meter per second square. And frictional force, what type of friction is acting? Kinetic friction is acting. So kinetic friction is 12 Newton. If external force less than 60 Newton ittu andre, adu alli friction will be static in nature. Okay, clear? So next problem we'll solve another problem on the friction only, but this time force is at a different angle. A force of 40 Newton, right? There is a force of 40 Newton. F 40 Newton is applied on the block in this direction. So is being applied on the block in this direction. There is a force of 40 Newton. So e force at a certain angle act ಆಗ್ತಾ ಇರೋದ್ರಿಂದ, so we can always resolve this force into 40 cos 30, right? 40 cos 30 and vertical component 40 sin 30. 40 cos 30 or 40 sin 30. So without writing the value, ಅರ್ಥ ಆಗಲಿ ಅಂತೇಳಿ ಸ್ಟಿಲ್ ನಾನು ನಿಮಗೆ F ಅಂತಾನೆ ಬರಿತಾ ಇದ್ದೀನಿ. F sin 30. So F sin 30 and F cos 30. ಸೊ ಡೈರೆಕ್ಟ್ಲಿ ನೀವು ಆ ಥರ ಬರ್ಕೋಬೋದು, ಬಟ್ ಸಿನ್ಸ್ ಫಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಇರೋದ್ರಿಂದ F cos 30 F sin 30 ಅಂತೇಳಿ ಬರಿತಾ ಇದ್ದೀನಿ. ಸೊ ಬ್ಲಾಕ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ಇರೋದ್ರಿಂದ, ಸೊ ದೆರ್ ಇಸ್ ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್ ಆ್ಯಕ್ಟಿಂಗ್ ಅಪ್ವರ್ಡ್ಸ್. Correct? Normal reaction acting upwards and its own weight mg acting downwards. This own weight mg ಏನಿದೆ 4 into 10, which is 40 Newton ಇದೆ. So if this F sin theta, which is F sin 30, is more than 40, then only block will accelerate upwards. See, F is 40, sine 30 is off, so this F sine 30 is less than mg, or because 20 is less than 40 in y direction, the block is in equilibrium, right? In y direction the block is in equilibrium. So in y direction barita idini equilibrium andre n plus f sine 30 is equal to m into g. So I'm not going to do anything in y direction because we need to calculate the acceleration of the block. Acceleration of the block is in which direction? We don't know. First of all, we have to calculate the static friction value. So for that, there is a block 4 kg whose x component of force is, what is the x component of force? F cos 30, and there is going to be friction in opposite direction. What is the nature of friction? Adana first calculate madana. So for that, we always start with calculating Fs max value. Then only I'll know whether applied force enide F cos 30 in x direction enough idyo ilvo motion anna cause ಮಾಡಕ್ಕೆ ಅನ್ನೋದನ್ನ ನೋಡಬೇಕು ಅಂದ್ರೆ Fs max ಬೇಕು. Fs max ಏನು? μs into n. μs ಏನು? μs is 0.6 into correct 0.6 or 4? 0.5. So Fs ಏನಿದೆ 0.5 ಇದೆ, right? 0.5 ಇದೆ. We need the value of n. So how do we get this n value from here? See guys, this f sine 30 ಏನು? F sine 30 ಬಂದು 20. So from here n is going to be 40 minus 20, which is 20 Newton, correct? 20 Newton. So this n itself is not balancing alva. N plus f sine 30 together balancing 40. So this 20 plus this 20 together balancing 40. So n is 20. So this n is 20. So Fs max value ಎಷ್ಟಿದೆ? Fs max value is 10 Newton. So Fs max value 10 Newton ಇದೆ. And F cos theta ಏನಿದೆ? F cos theta, which is equal to F value ano 40 cos 30 root 3 by 2. So 40 root 3 by 2. So 40 root 3 by 2 or F cos 30 is greater than Fs max. Correct? Because 40 root 3 by 2 is greater than this value 10. So the type of friction is going to be kinetic friction. There is going to be kinetic friction. So the block will accelerate with acceleration A, correct? But how do we calculate that acceleration? By applying NLM in x direction. Apply NLM in x direction. In x direction ಅಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ NLM ನ. ಸೊ acceleration ಆ direction ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ net force F cos theta, which is 40 root 3 by 2 F cos theta minus Fk should be equal to what? Mass into acceleration, right? Mass into acceleration. So F cos theta, which is 40 root 3 by 2, Fk value ಏನಿದೆ? Fk is mu k into n, correct? Fk is mu k into n. Here I am writing Fk is mu k into n. See, observe the diagram. Mu k ಏನಿದೆ? 0.3 ಇದೆ, ಕರೆಕ್ಟ್? 0.3 ಇದೆ. ಸೊ 0.3 ಇದೆ. ಸೊ 0.3 into n ಏನಿದೆ? n is 20. So FK value is 6 Newton. So FK value is 6 Newton there. So directly you can write FK value 6 Newton. So FK value 6 Newton, which is equal to mass into acceleration. Mass is 4, acceleration is unknown, correct? So 40 by 2, which is 20√3 minus mu k, which is 6, equal to 4 into acceleration. So acceleration is simply going to be 20√3 minus 6 divided by 4. 20√3 minus 6 divided by 4. Let us check the answer. 7.1 meter per second. So answer is 7.1 meter per second. How do we get 7.1 meter per second from here? So 20 into root 3. 20 into root 3. So see, 20√3 by 4, which is 20√3 by 4, which is 5√3 minus 6 by 4, which is 6 by 4 is 3 by 2. 5 into 1.7, 5 into 1.7, 5 into 1.7 minus 1.5. 5 into 1.7 minus 1.5. 17 times the 5. 17 times the 5 is what? 85. So it is 8.5 minus 8.5 minus 1.5. 8.5 minus 1.5, which is close to, or which is exactly equal to 7. But this root 3 is more than 7. So answer should be close to 7 and more than 7. So by that logic you can calculate, you can tick the answer, but answer you can directly write acceleration is going to be 7.1 meter per second square. 7.1 meter per second square. Okay. So next problem. So we look at the last problem of friction. So I hope everything is getting cleared from these problems. ಇಲ್ಲಿ ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ? Force of 50 Newton is applied on the block. A force of 50 Newton is applied on the block of mass 2 kg. So ಈ ಬ್ಲಾಕ್ 2 kg ಇದೆ, ಅದ್ರ ಮೇಲೆ ನಾವು 50 ನ್ಯೂಟನ್ನ ಈ ಥರ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಬಟ್ ದಿಸ್ ಟೈಮ್ ಇಟ್ಸ್ ವೆಯ್ಟ್ ಏನಿದೆ ಇಸ್ ಆ್ಯಕ್ಟಿಂಗ್ ಡೌನ್ವರ್ಡ್ಸ್. ಓಕೆ, ವೆಯ್ಟ್ ಇಸ್ 2 kg, 2g ಇಸ್ 20 Newton. 20 Newton ವೆಯ್ಟ್ ಈ ಡೈರೆಕ್ಷನಲ್ಲಿ ಇದೆ. ಫೈಂಡ್ ದ ಆಕ್ಸಿಲರೇಷನ್ ಅಂಡ್ ಫ್ರಿಕ್ಷನ್ ಆಫ್ ದ ಬ್ಲಾಕ್ ಆನ್ ದ ಬ್ಲಾಕ್. ಸಿ, ಇಲ್ಲಿ ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್ ಯಾವ ಡೈರೆಕ್ಷನಲ್ಲಿದೆ? ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್ ಈ ಡೈರೆಕ್ಷನಲ್ಲಿ ಇದೆಯಾ? ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್ ಆ ಡೈರೆಕ್ಷನಲ್ಲಿ ಇರಬೇಕು ಅಂದರೆ ಇಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಸರ್ಫೇಸ್ ಇರಬೇಕು, ಬಟ್ ಅದು ಆಗ್ತಾ ಇಲ್ಲ. ಬಟ್ ಇನ್ ದಿಸ್ ಕೇಸ್ ಏನಾಗ್ತಾ ಇದೆ ಅಂದರೆ ಸರ್ಫೇಸ್ ಇಸ್ ಆ್ಯಕ್ಚುಲಿ ಇಯರ್. ಸೊ ಈಗ ನಾವು 50 ನ್ಯೂಟನ್ ಫೋರ್ಸಲ್ಲಿ ನಾನು ಈ ಥರ ಪುಷ್ ಮಾಡಿದರೆ ವಾಲನ್ನು, ರೈಟ್, 50 ನ್ಯೂಟನ್ ಫೋರ್ಸನ್ನು ನಾನು ವಾಲ್ ಮೇಲೆ ಹಾಕಿದರೆ, ರೈಟ್, 50 ನ್ಯೂಟನ್ ಫೋರ್ಸನ್ನು ನಾನು ವಾಲ್ ಮೇಲೆ ಹಾಕಿದರೆ ವಾಲ್ ವಿಲ್ ಆಲ್ಸೋ ಅಪ್ಲೈ 50 Newton force in this direction, correct? So this is your normal reaction. This is normal reaction. F is normal reaction. This F is normal reaction. Okay, this F is normal reaction. So normal reaction F 50 Newton ಇದೆ ಅಂದರೆ ಸೊ ನಾನು ಫ್ರಿಕ್ಷನ್ ವ್ಯಾಲ್ಯೂನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೋದು. F is 50 Newton. But what type of friction we always calculate? We always calculate the limiting value of static friction. Fs max ಅನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀನಿ. ಬಿಕಾಸ್ Fs max ಗೊತ್ತಿತ್ತು ಅಂದರೆ ನನಗೆ ಗೊತ್ತಾಗುತ್ತೆ ಬ್ಲಾಕ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆಯೋ ಇಲ್ವೋ ಅಂತ. ಫಸ್ಟ್ Fx max ಹೆಂಗೆ ಬರಿತೀವಿ? μs ಇಂಟು n, ರೈಟ್, μs ಇಂಟು n. ಬಟ್ ಇಲ್ಲಿ n ಏನಿದೆ? ದಿಸ್ n is 50, ಕರೆಕ್ಟ್? This n is 50 because F external is what gives normal reaction. So μs is 0.5, n is 50. See guys, don't get confused. This F on the wall will be normal. F on the wall will be normal by the block on the wall. So on the wall is going to be by the block on wall. By the block on wall. So on the wall also 50, on the block also 50. So Fs max is going to be 25 Newton. Right? So this 25 Newton is acting in which direction? Is acting opposite to the relative slipping. So this Fs max is acting opposite to the relative slipping. So but only 20 Newton is there, right? So only 20 Newton is there. So there is going to be no acceleration. Why? Because applied force, applied or weight which is 20 Newton is less than Fs max. So only how much friction will act? Only 20 Newton of Fs will act opposite to weight. That is why this is Fs. Now it is not kinetic friction. The nature of the friction is kinetic, and this value of acceleration is 0. Why? Because friction is not letting the block move down. Friction is not letting the block move down, and whose value is Fs, which is 20 Newton, acceleration which is 0 meter per second square. Right guys, we have solved all the category of problems in friction. Friction alli ಏನೆಲ್ಲ ಮಾಡಕ್ಕೆ ಸಾಧ್ಯನೋ ಅದೆಲ್ಲ problems na solve ಮಾಡಿದ್ದೀನಿ. Problems in the, I hope you have understood how things work in the chapter of friction along with NLM. So we are providing a very good set of DPP problems based on these set of understandings. So go solve all the problems. I will see you in the next class with the problems based on friction in a circular tracks and banked inclined tracks. Okay, so thank you for watching this class everybody. Thank you so much. We will see you in the next class. Thank you.